All right, today we're looking at proofs, and we're going to start with algebraic proofs because algebra is something you guys are already familiar with. So when we look at proofs, we're thinking of kind of like playing Uno. For every step that we take or every card that you lay down in Uno, there has to be a reason or a justification. So in our game of Uno, it's going to take a second to load here. If we're given a red 0, how can we prove a yellow 4? Oops. I'm going to try to see if I can drag these cards out from behind here so we can see what we're working with. And again, with every card that we lay down, we have to provide some sort of reason or justification as to why we can play that card. All right, we're gonna hit some problems here trying to get this stuff out. All right, so maybe, there we go. Okay, so given the red 0, how do we prove the 4? Well, we start with what's given, which in this case is going to be that red 0 card. So you're always going to start with what's given because that's really the only information that you have to work with at the beginning. Okay, so we have our red 0. That's what we're given to start with. Now, the next move that I can make here, if I look at these cards off to the left, the next card that I can lay down is going to be the red 7. Okay, so with the red 7, my reason or my justification is that they're the same color. Okay, once I have the red 7 down, again, if we're playing Uno, it's someone else's turn. Next card choice that I have is a blue 7. So I could add that to the pile. Because they're the same number. So again, every time we lay a card down, we have a reason as to why we're allowed to lay that specific card down. Next card we could lay down would be the blue 1. Because they are the same color. All right, from there, most of you now can kind of see the finish line. We have the yellow 1, which I can lay down because they are the same number. And then I have the yellow 4, which is what I'm trying to prove up here, which is where I want to end up. I want to end up with what they're asking me to prove, the yellow 4, and that's because they are the same color. So when we're looking at proofs, they give us what we start with, and they give us what we need to end with or what our answer needs to be. We have to fill in everything in the middle that tells us what and why. So properties of equality, these are things that you should have done in Algebra 1. When we are looking at properties of equality, these will end up becoming some of our reasons. Or some of our justifications in our proofs. So for the first one, our addition property of equality, if A, let's see, equals B, then A plus C equals B plus C. Subtraction property of equality is very similar. If A is equal to B and then I subtract the same thing from both sides, they're still going to be equal. Multiplication property of equality is the same thing. If I start with two things that are equal and I multiply them by the same thing, then they're still equal. And then division property. If I start with two things that are equal and I divide both sides by the same thing, they're still equal. A distributive property, this would be like our rainbows. So if I have A times B plus C, that's the same as AB plus AC. Substitution, if two things are the same, so if A equals B, then A may be replaced by B in any equation. Okay, as long as they're equal, replacing them doesn't actually change anything. For reflexive property, we're looking at, for any real number A equals A. Anything is equal to itself. For symmetric property, this just means it can go backwards. So if A equals B, then B equals A. Transitive is a little bit different, maybe a trickier one, but if A equals B and B equals C, then A equals C. Okay, so if they're equal right here, A and C are both equal to B, so if they're equal to the same thing, then they're equal to each other. So this would be an introduction to what we can use then in our two-column proofs. So the left side is where we have our statements or our steps. And the right side is where we list the reasons that justify each step. So what rule do we have that we can use to justify? Now, for these justifications, we can use properties. We can use definitions. We can use postulates. And we can use theorems. Any of those things would be allowed to be used on that right-hand side. The only other thing that you're going to see on a right-hand side that's not a property, definition, postulate, or theorems would be the things that are given to you. Okay, if the question tells you that something is true, then you use that in your statement. You guys can go ahead and check out the next video to go through some of these algebraic proofs.